Hey, okay, so I'm going to dig into the law of cosines really quickly. You guys can see me in your screen. How fun is that? Okay, so we're going to go through this proof right now. So kind of similar to the law of sines in the sense that like we don't have a right triangle, right? So we got to figure something else out. I'm going to go through the proof of how they got this formula. So first thing I'm going to do is I'm going to drop an altitude. So I can get two right triangles. So I'll have this yellow right triangle here, and then the green right triangle. So now I've got two right triangles that I can like work within and try to do some trig with. So let's actually look at side C here. We're going to relabel side C. Because I don't know these distances here, I'm going to call this one X and this one C minus X. So you can see that both of these add together to be C. And if you don't believe me that they add together to be C, X plus C minus X is just C. So we're going to relabel the bottom. And I'm going to call this altitude H. So looking at the yellow triangle, I'm going to do the Pythagorean theorem, and I will get x squared plus h squared equals b squared. And this is from the yellow triangle. And from the green triangle, I'll do the Pythagorean theorem again, and I will get h squared plus c minus x squared equals a squared. Kind of similar to the law of sines, where like we're going to get rid of this like h value in there. First thing I'm going to do is I'm going to, this is from the green triangle, I'm going to expand out this piece and kind of simplify it a little bit more. So let's see, this will be h squared plus c squared minus 2cx plus x squared equals a squared. And again, all this is right here, it's just coming from expanding this piece out. And then over here, I'm just going to solve this for h, so I can substitute it in. So h squared equals b squared minus x squared. So I'm just going to substitute this piece in right here for h squared. So now we're kind of like getting rid of some of our variables that like we don't really need right now. So this will turn into b squared minus x squared plus, again, that's what h squared is, plus c squared minus 2cx plus x squared equals a squared. And I'm going to rewrite this a little bit because it looks a little funky. So we'll have it's a squared equals b squared plus c squared minus 2cx. So that is just this whole thing like rearranged. The last piece of it, like this formula isn't really helpful to us yet because we don't know what this x is. So we got to try to find a way to replace this x. So let's go back to our original triangle over here, and let's look at the yellow side. So we want to come up with an equation that has x in it so we can replace it. So let's look at the yellow triangle. And if you note, this is the law of cosines, so we will do the cosine of angle A equals adjacent x over b. So that means x is equal to b times by the cosine of A. This is perfect. We can substitute b times the cosine of A in for x. And so we end up with a squared equals b squared plus c squared minus 2c times by, and I'm going to substitute this in, b times the cosine of a. So this is the law of cosines. Generally, I actually like to rewrite these so it kind of matches the order here, b and c. So I'm going to rewrite that as a squared equals b squared plus c squared minus 2bc times by the cosine of a. Now this formula is a beast. This is the law of cosines. A couple things that kind of like help me remember it when I think about this formula. So this is the formula you will need to be working with. Is to notice that like this side, a squared, is always the side that's inside of the cosine, or the angle that's inside of the cosine. Like those will always match. It doesn't matter what order you add these in, obviously, because they're being added. And it doesn't matter what order you multiply those in, right? So you could do c squared plus b squared, doesn't matter. It's just the other two sides. And you can do c times b, doesn't matter. It's just the other two sides. This is the formula. It works for any side. And you're going to need to be able to like use this formula when you can't use the law of sines. So always check if you can use the law of sines first, because it's much faster and easier. And if you can't, you'll likely have to use the law of cosines. So we'll do one problem together here. This problem right here. First thing I'm going to do is check, can I do the law of sines? Well, let's see here. I've got this angle and the corresponding side. That's good, but I can't use this side and this angle. So that means I cannot use the law of sines. So I'm going to have to use the law of cosines here. So let's see. I'm going to make this my A, angle A right here. So that means this is little side A, and it doesn't matter which one of these I make, B or C. So that means this could be little c, or this could be little c. The important thing is angle A has to be the angle that we know. Like that's the important piece here. So we will write all this out now. And we end up with x squared equals b squared is going to be 20 squared plus c squared is going to be 23 squared minus 2 times by b, which is 20, times by c, which is 23, times by the cosine of 119 degrees. So you do some algebra in here, and you can simplify all this. So I'm going to go through the steps to do it. 20 squared brings out 400 plus 23 squared brings out 529 minus, I like to multiply these out. So let's see, what is 2 times 20 times 23? So minus 920 times by the cosine of 119. So we can do some simplifying. Remember, you cannot combine these, right? Like these are not like terms right now. You can't combine them because of the cosine in there. So let's add these two together. So we get 929 minus 920. So this is equal to x squared. 920 times by the cosine of 119. I'm just going to type this in my calculator right now. 929 minus 920 times by the cosine 119. And I get x squared is equal to 1375.024851 to solve for x. Lastly, I just have to do the square root. So take the square root of both sides. and you get x is approximately 37.08. Okay, so that is the law of cosines. We're going to practice this again on Monday or Tuesday whenever I see you next. But yeah, again, sorry for the internet stuff at York. Shoot me an email or Gmail if you have any questions or want to go through this. You should be able to use this formula now for the homework. Okay, thanks guys, bye.